Today, we're going to discuss about the first order differential equations. So in these forms of linear differential equations, we have two forms. We have dy over dx plus p of x of y is equal to q of x. It is linear in y. Now, if the equation is linear in y, then you have to use the equation of y raised to the integral of p of x dx is equal to the integral of q of x times e raised to the integral of p of x dx of dx. Now, this e raised to integral of p of x dx is what we called as the integrating factor. Now, the other form is in terms of linear in x. So, we have dx over dy plus p of y of x is equal to q of y. So, if that is the given equation, then use now the equation of xe raised to the integral of p of y dy is equal to the integral of q of y times e raised to the integral of p of y dy of dy. So, in the same manner, e raised to the integral of p of y dy is actually the integrating factor. Now, how are we going to find the solution using the first order differential equations? So, step number one, you are going to rewrite the given in terms of the standard form. So, the standard form that I'm talking about is this one that I mentioned earlier, the one that I check it now. So, those are the standard forms. Now, after writing the equation into a standard form, identify the value of p of x, the p of x, and the q of y, or p of y and the q of y. Now, after you have identified the value of those functions, then solve for the integrating factor. So as I've said earlier, the integrating factor is e raised to the integral of p of x dx. Or I will write it here below that the integrating factor. So we have the formula of e raised to the integral of p of x dx, or we have the e raised to the integral of p of y dy. So that is our step number two. Solve for the integrating factor. Then step number three, you are going to use the given equation, whether the first one or the second one, whichever is equation is linear in two. It's either linear in y or linear in x. So use these equations. Then after that, you simplify the right hand side. Then after you simplify the right hand side, then you are going to integrate in order for you to solve the solution. So those are the steps in solving the first order linear differential equation. Now let's put that one now into example. So solve the differential equation of dy over dx plus 3x squared y is equal to 6x squared. Now, looking at the given, so compare that one to our standard form, which is dy over dx plus p of x of y is equal to q of x. So, we are going to get the value p of x, which is now, so 3x squared is the value of p of x is equal to 3x squared, and the value of q of x is, we have 6x squared. So we have now 6x squared. So since the given equation is already in the standard form, so we are done with the step number one. So step number two is determining or identifying the value of p of x and q of x. So we are done. So the third step now is to solve for the integrating factor. Now to solve the formula to be followed, so e raised to the integral of p of x dx. So by substitution, because we know already the value of p of x, so we have now e raised to 3x squared of dx. So integrating this one, the exponent, we have 3x squared. So the integral of the exponent now will give us e raised to x cubed. So this is now the value of our integrating factor. Now, after knowing the integrating factor, now we are going to solve for the equation. Since this is linear in y, then we're going to use this formula. Y e raised to the integral of p of x dx is equal to the integral of q of x times e raised to the integral of p of x dx of dx. Now, since we have solved earlier the value of the integrating factor, which now e raised to x cubed, now we're going to use substitution. So we have now y, the value of this is this one. So we have e raised to the integral of p of x dx, which is now equal to the e raised to x cubed. So I will write now e raised to x cubed is equal to the integral of the q of x is 6x squared times the integrating factor, which is now times e raised to x cubed and dx. Now, we are going to simplify our integrand on the right-hand side. Y e raised to x cubed is equal to 6 times x squared times e raised to x cubed dx. What I did here is only writing the coefficient factor outside the integral sign. Then, we are going to let u is equal to x cubed and du is equal to 3x squared dx. Now comparing the du, I can have 3x squared dx. So I highlighted the x squared dx because I can see that there is x squared dx in our right hand side. Now I'm going to define that one. So by determining the meaning of x squared dx. So in that case, since we have 3x squared dx, so we have to eliminate 3. Therefore, we divide by 3. Therefore, we have x squared dx is equal to du over 3 or 1/3 of du. Now, after determining the value of u and du, so we can rewrite now the given in terms of u and du in the right hand side. So from here, we can now have y e raised to x cubed is equal to 6 times the integral of, so e raised to x cubed can be written now as e raised to u, and x squared dx can be now written as du over 3. So writing now the coefficient, the numerical coefficient outside the integral sign, so we can write now ye raised to x cubed is equal to 6 times 1/3 the integral of e raised to u du. So our integral now is very easy to integrate. So therefore, we can now simplify our answer as y e raised to x cubed is equal to 6 times 1/3 is 2, and the integral of e raised to u du is e raised to u plus a constant. Now after that, we are going to substitute back the meaning of u. So y e raised to x to the power of 3 equals 2e raised to, the u here is x cubed, so I can write now x to the power of 3 plus a constant. So I want you to write your answer in terms of y because this is linear in y. So in that case, class, I want to eliminate or I want to solve for y. So therefore, I want to eliminate the e raised to x cubed. So you can divide the entire equation by e raised to x cubed, or you can multiply by 1 over e raised to x cubed. So multiplying that one, so we can now write the 1 over e raised to x cubed times this entire equation. So therefore, we can write now y is equal to e raised to x cubed divided by e raised to x cubed is 1. So therefore, 2 plus c over e raised to x cubed. Or if you don't like to write a fraction form, you can write now as y is equal to 2 plus c times e raised to the negative x cubed. So they are just the same. So this is now the answer for number 1. Now for number 2, we have find the solution of initial value problem. So I talk here about initial value problem, but our topic for today is about the first order differential equation. So meaning to say, we just integrate our previous topic, which is now the initial value problem. But of course, we have to solve first using the first order differential equation, wherein y of 1 is equal to 2 provided that x is greater than 0. Now, since the given is not in the standard form, then I will divide first the entire equation by 1 over x squared. So, if using distributive property, so 1 over x squared times x squared y prime. So, the product now is y prime plus xy divided by x squared. So, we can write now as y over x is equal to 1 over x squared. This is where this condition of x is greater than 0, because if x is equal to 0, then this becomes undefined. All right. Now, we are going to identify our p of x as well as the q of x. So in order for you to see clearly what is the value of p of x, I can rewrite this one as y prime plus 1 over x of y is equal to 1 over x squared. So by this time, it's very clear that the value of p of x is 1 over x. So therefore, I can write now p of x is equal to 1 over x, and the q of x is equal to 1 over x squared. So next is we are going to use the integrating factor. We have e raised to the integral of p of x dx is equal to e raised to, the value of p of x is 1 over x dx. Then we take the integration of that. It gives us the answer of e raised to ln of x, and then simplifying the e raised to ln of x. So therefore, the answer now for integrating factor is just equal to x. So x now is equal to e raised to, so the integral of p of x dx, and we know that the left hand side is what we called as the integrating factor. Now, after knowing the value of the integrating factor, we are now going to use the equation. So since that is linear in equation, so use the formula. So using the formula of y times e raised to the integral of p of x dx is equal to the integral of q of x times e raised to the integral of p of x dx of dx. So by substitution, since we know already the value of the integrating factor, so we can just substitute now the given. So we have finding the value of the integrating factor, which is the e raised to the integral of p of x dx, which is equal to x. So by substitution, we have now y, the value of e raised to the integral of p of x dx is x. So we have yx is equal to the integral of q of x is 1 over x squared times x dx. Now, simplifying the right-hand side, we have yx or xy is equal to the integral of 1 over x dx. So, y over x is equal to the integral of 1 over x dx is ln of x plus a constant. So, since I want you to write your answer in terms of y, because this is linear in y, so therefore divide both sides by x. So therefore, y of x plus a constant all over x. Now, since there is an initial value condition, so we have, since y sub 1 is equal to 2, replace x now by 1. So therefore, 2 is equal to ln of 1 plus a constant all over 1. So cross multiplication, or 2 times 1 equals 2. ln of 1 is equal to 0. Okay, so therefore C is equal to 2. So we have C is equal to 2, or C is equal to 2. Now, after knowing the value of C, then we have to go back to this formula, and we are going to substitute the value of C. Therefore, y is equal to ln of x plus the value of C now is 2 all over x. Or you can write here now as y of x is equal to ln of x plus 2 all over x. So next problem is solve the following IVP, which stands for initial value problem, with the equation of cosine x y prime plus sine x y is equal to 2 cosine cube x sine x minus 1, where y of pi over 4 is equal to 3 square root of 2, and the condition that and provided that x is greater than is equal to 0, or x is less than pi over 2. So remember that the first step is we are going to write the equation into a standard form. So therefore, we are going to multiply the entire equation by 1 over cosine x. So distributive property, therefore this is now cosine x y prime divided by x. So we have now y prime plus sine x of y divided by cosine x. We have now tangent of x of y, because sine x over cosine x is equal to tangent x is equal to 2 cosine cube x sine x divided by cosine x. So the quotient now we have 2 cosine squared of x sine x minus 1 over cosine x times negative 1 is 1 over cosine x, or you can write the identity of 1 over cosine x as secant x. Okay, so next is we are going now to identify the p of x and the q of x, since this is already now in the standard form. So we can see that the value of p of x is tangent of x, and the value of q of x is actually this one. Okay, so this is now our q of x. So next is that we are going to solve for the integrating factor. We have e raised to the integral of p of x dx is equal to e raised to tangent x dx. So we have to find the integral of tangent x dx. So it gives us the integration of ln of e raised to ln of secant x. So simplifying that one, the e and the ln will be simplified. So we have now the value now of the e raised to the integral of p of x dx is just equal to secant x. So this is now our integrating factor. Now, after knowing the integrating factor, we are now going to use the equation. So the equation that we use, since it's linear in y, we have now y e raised to the integral of p of x dx is equal to the integral of q of x times e raised to the integral of p of x dx of dx. So by substituting the value of the integrating factor, so we can write now as y, then the meaning of this e raised to the integral of p of x dx, which is actually now the secant x. So I can write now as secant x is equal to the integral of q of x, which is now 2 cosine squared x sine x minus 1 over cosine x times the integrating factor is secant x, or we can write here as 1 over cosine x dx. So take note that in the identity, so secant x is just equal to 1 over cosine x. Now I can write here as y secant x is equal to, so multiplying this one, 2 cosine squared x sine x times 1 over cosine x. So the quotient is just 2 cosine of x sine x minus 1 over cosine x times 1 over cosine x is equal to 1 over cosine squared x. And 1 over cosine squared x can be written now as secant squared x dx. Now I'm going to separate the two terms. So we can write now as y of secant x is equal to the integral of 2 cosine x sine x dx minus the integral of secant squared x dx. So on the first integrand, or the first term on the right hand side, it has an identity of sine 2x. So therefore, rewriting that one, we have y times secant x is equal to the integral of sine 2x dx minus the integral of secant squared x dx. Now we can take the antiderivative on the right hand side. So we have now y secant x is equal to negative 1 half of cosine 2x minus the integral of secant squared x dx is equal to tangent x. So minus tangent x, then plus a constant. Now, since I am requiring you to solve for y, therefore I will multiply the entire equation by 1 over secant x, or simply divide by secant x. So I will write now 1 over secant x. Okay, so by multiplying that one now, so we can have the answer of y on the left hand side is equal to negative 1 half. I will write it first here. Negative 1 half of cosine 2x all over secant x minus tangent x over secant x plus a constant. Now simplifying this one, so okay, I will just write here the last equation. We have y is equal to negative 1 half of cosine 2x all over secant x minus tangent x over secant x plus c over secant x. Okay, there must be here. The last term should be plus c over secant x. Now simplifying that one, it is here. So since the denominator is secant x, and that is now can be written on the numerator, but you have to take the identity, or the reciprocal identity. So we can write now as y equals negative 1 half of cosine x times cosine 2x minus, so simplify tangent x over secant x. All you have to do, convert that one first into sine over cosine. So we have now tangent x is sine x over cosine x divided by, there is we have secant x is 1 over cosine x. Then take the reciprocal for this, 1 over cosine. So therefore, the quotient now is equal to sine x. So I can write now here as sine x plus c over. So instead of writing c over secant x, I can write now c times cosine x. So this is now the solution to the problem. But there is the initial value condition that y of pi over 4 is equal to 3 square root of 2. So using that value, okay, we have since y of pi over 4 is equal to 3 square root of 2. So I will replace x now by pi over 4. And this will be equated to 3 square root of 2 is equal to the negative 1 half of cosine pi over 4 times cosine of 2 pi over 4. It gives us now cosine of pi over 2 minus sine pi plus c times cosine of pi over 4. So using the value, or taking the value of cosine pi over 4, so we have negative 1 half. So cosine pi over 4 is square root of 2 over 2. So we can write now times square root of 2 over 2. Then cosine of pi over 2 is 0 minus, okay, correction, this must be sine of pi over 4. So sine of pi over 4 is also square root of 2 over 2 plus c times square root of 2 over 2. So simplifying, so the first term here on the right hand side, since multiplying any number multiplied by 0 is 0, so that's now 0 here. And then transpose the negative square root of 2 over 2. So we can write now as 3 square root of 2 plus square root of 2 over 2 is equal to the square root of 2 over 2 times c. Now simplifying first the left hand side, so we can write now as the LCD is 2 times the numerator. We have 6 square root of 2 plus 2 divided by 2 is 1 times square root of 2. We have square root of 2 is equal to the right hand side square root of 2 over 2 times c. So simplifying further on the left hand side, so we can write now we have 7 square root of 2 over 2 is equal to square root of 2 over 2 times c. Now to solve for c, I will just multiply the entire equation by its reciprocal of the coefficient of c, which is now 2 over square root of 2. Or if you like, you can divide the entire equation by square root of 2 over 2. So simplifying that one, it will give us the value of c is equal to 7. Now, since we know that c is 7 now, we can go back to the equation that we have derived. So we can write now as, therefore, the solution now will become y is equal to the negative 1 half of cosine x cosine 2x minus sine x plus the value of c, which is now 7. So 7 of cosine x. So that's now the answer for that problem. So next is, so find the solution of the differential equation. So we have here x plus 2y of dx minus x dy is equal to 0. So first of all, our goal is to transform that one into a standard form. So using first distributive property, so I have now x dx plus 2y dx minus x dy is equal to 0. Now, after that, we are going to transpose x in the dy. So I can write now x dx plus 2y is equal to x dy. Now, still, the given equation here is not in the standard form. I'm going to divide first by dx. So we are going to multiply by 1 over dx. So 1 over dx times x dx, so dx is cancelled. So we have x plus 2y dx over dx. Therefore, we have 2y of dx. Dx and dx will be cancelled. So we're therefore it's only have 2y is equal to, okay, so this is now equal to x dy over dx. So I'm going to divide by x in order for us to eliminate x on the right hand side. So multiplying this again by 1 over x. So we have now 1 over x times x is equal to 1 plus this is now 2 over x of y is equal to dy over dx. So it's not yet in the standard form. So I will transpose and rewrite this one into a standard form. So I can write now dy over dx. So transpose the 2 over x of y. It becomes negative 2 over x of y is equal to 1. So from here, we know that our p of x is equal to the negative of 2 over x and our q of x is equal to 1. Now solving for the integrating factor, we have e raised to the integral of p of x dx. So this will be now e raised to the integral of p of x dx is we have now negative 2 over x dx, and take the integration on the exponent. So the integral of negative 2 over x dx is equal to we have e raised to the negative 2 ln of x. So rewriting this one, we can write now as e raised to ln of x to the power of negative 2. So simplifying further, the e and the ln will be cancelled. So therefore, the value now of the integrating factor is equal to x to the power of negative 2. So we will use this one to substitute to our equation. Now, since this is linear in y, so the equation now we have y e raised to the integral of p of x dx is equal to the integral of q of x times e raised to the integral of p of x dx of dx. So by substituting the value of e raised to the integral of px dx, this one, which we solved earlier, that is now x to the power of negative 2. So we can write now y times x to the power of negative 2 is equal to the integral of the value of q of x is 1. I will just write there 1 times the integrating factor now is x to the power of negative 2 of dx. So integrating now on the right hand side, we can write yx to the power of negative 2 is equal to x to the power of negative 1 over negative 1 plus a constant. Or we could write yx to the power of negative 2 is equal to the negative of 1 over x plus a constant. Now solving for y, so we can write now y. So you can divide the entire equation by x to the power of negative 2, or you can multiply by x squared. They are just the same when you're going to divide by x to the power of negative 2. So multiplying that one, so we have x squared times y x of negative 2. So the answer becomes y is equal to x squared times negative 1 over x. So that is now negative x plus cx squared. So this is now the answer for our problem. So the next problem must be y dx plus the quantity of 2x minus xy plus 3 of dy is equal to 0. That's so correction to the problem. There must be dy after the quantity. Now, first thing that I'm gonna do is that I will use distributive property to remove the quantity there of dy. Now we have y dx plus 2x dy minus xy dy plus 3 dy is equal to 0. So next is I'm going to factor the second term and the third term. So a common factor there is x and dy. So we can write here x times the quantity of dy. So now let's divide 2x divided by x. So we have now 2 minus xy divided by x, we have y, and then I write another common term or common factor of dy plus 3 dy is equal to 0. So next is that I'm going to divide by dy so that this 3 becomes a constant. So therefore, I will multiply the entire equation by 1 over dy. So using distributive property, so we can write now as y of dx over dy plus, so the dy here will be cancelled. So we have now x times 2 minus y plus, so we can also cancel the dy, therefore we have only 3 is equal to 0. So still, there is a coefficient of y in the dx over dy. So to remove that one, we are going to multiply the entire equation by 1 over y. So therefore, we have now dx over dy plus I will rewrite this one as 2 minus y over y of x plus 3 over y is equal to 0. So next is that we are just going to transpose the 3 over y in order for us to come up in the standard form. So we have now dx over dy plus 2 minus y over y. I will try to divide that one. So dividing that one, we have now 2 over y minus y over 1 is 1 of x is equal to negative 3 over y. So that is already now in the standard form. So we can write now the value of p of x is equal to 2 over y minus 1 And then the value of q of x is equal to the negative 3 over y. So take note that is now dx over dy. So meaning to say we are dealing with the differential equation that is linear in x. So correction to that, this must be p of y, p of y, and this one also must be q of y. This is now q of y. Now after that, we are now going to take the integrating factor, which is now e raised to the integral of p of y dy. So by substitution, we have uh, e raised to the integral of p of y is 2 over y minus 1 of dy. So by integrating that one, we can write the answer of e raised to 2 ln of y minus y. And rewriting this again, that is now e raised to ln of y squared minus y. So let us separate the two terms in the exponent, that it can be also written as e raised to ln of y squared times e raised to negative y. So e raised to ln must be cancelled. So we have now the value of y squared times e raised to negative y as the integrating factor. We have e raised to the integral of p of y dy. So we now have the value of the integrating factor. Now we are going to substitute to the formula. So using the formula that is linear in x, so we can write now as we have x e raised to the integral of p of y dy is equal to the integral of q of y times e raised to the integral of p of y dy. So by substituting the integrating factor, and we can now have x times y squared of e raised to negative y is equal to the integral of q of y is negative 3 over y, and the integrating factor is y squared times e raised to negative y of dy. So simplifying the right hand side, we can write now x y squared of e raised to negative y equals negative 3 times the integral of y squared over y is only y. So we have y e raised to negative y dy. So in this case, class, our integrand can be solved using the integration by parts. So recall, we have to recall that the integral of u dv is equal to uv minus the integral of v du. So in our problem, we have the integral of y e raised to negative y dy. So we let u there is y, and our dv is the remaining terms. If y is our u, therefore dv, this is the remaining terms, which is e raised to negative y of dy. Now, solve for du. Our du is derivative of y is dy, and our v, the integral of e raised to negative y dy, is equal to the negative of e raised to negative y. So rewriting the last equation there, we have all right. So we have x y squared of e raised to negative y equals negative 3 times. So the integral of u dv, we have uv minus the integral of v du. So our u times b is y times negative e raised to negative y. So we can write now as negative y e raised to negative y minus the integral of v du. Our v is, we have negative e raised to negative y, and our du is just dy. So we can write here dy. So simplifying the second term first, so I can write now xy squared of e raised to negative y equals negative 3 times negative y times e raised to negative y. So negative times negative is positive. And then the integral of e raised to negative y is negative e raised to negative y, and then plus a constant. Now, using distributive property and multiply by negative 3, so we can write now as x y squared of e raised to negative y. So negative 3 times this negative y e raised to negative y is 3y e raised to negative y. So positive times negative is negative times negative outside negative 3. So therefore, we have now positive 3e raised to negative y plus a constant. Now, I'm going to divide first by e raised to negative y. So dividing the entire equation by e raised to negative y, or multiplying by e raised to y. So they are just the same. Okay, so multiplying that one now. So we have x y squared is equal to 3y plus plus 3 plus c of e raised to y. So you can stop your answer here, or since I am requiring you to write the answer in terms of x or y, it depends whether it is linear to x or linear in y. But since this is linear in x, so therefore we solve for x. So therefore we have x is equal to, divide the entire equation by y squared, so we can write now 3 over y plus 3 over y squared plus c e raised to y over y squared. So that's now the answer for that.